Welcome back. So today I'll give you a small demo on R, the interface, how to use R and the interface that we use. In fact, the IDE that we use, RStudio. Uh, Before getting into the details of R and RStudio, let me just point out this thing. R is a statistical language that has been used by people for a lot of years now. But RStudio is an IDE. It's a very famous IDE that was built on top of R. So if you're trying to install and if you're trying to work on RStudio, what you have to do is you have to install R setup first, and then on top of it, you have to install your RStudio. So let me start by sharing my screen with you guys. Just give me a minute. Okay. So this is my RStudio. Let me just clear everything. This is my RStudio. Okay, it's divided into four, panels or four windows, small sub windows. First, this is my editor, script editor. Here I write my scripts, and it's like Python. Whatever code you write in R, it's called as R script. So whatever code I'm going to write, I'll be writing here in my script editor. This is my console window. Again, it's like IPython. I don't have to spare whatever I want to run. I can write the code in my R script and then I can run it. Or if I don't want to write a code and if I just want to directly do something, I can do it here in my console as well. This panel here is for my my plotting plots and everything. And this panel here, I can see all my variables, my global variables and everything here in this panel. Let me start by showing you something. Let's say we have an area variable A. And I want to assign a value of 2 to my A. So the way I can do it is using A is equal to 2. When I press enter, I got A as 2. And you can see A is here. My variable A is here. Similarly, if I want like B to be a 9, I can do that. I am getting B here. A plus B, I get A plus B. I want to do A into B, I can do A into B. I don't even have to write the code here in my script editor. And generally, we write code in script editor when we are doing heavy processing or if you are writing a heavy code. So let's say I have. Let's just begin with some advanced stuff. So let's say I have I have a data in my my desktop, and the name of the data is the data complete data stored in rel.csv file. Let me start by reading the data file, and I will store whatever values I have in that CSV file into this variable RR. So let me start by copying and pasting it in my console window. I press enter, and immediately we can see we have a variable RR here. Let's inspect what's inside RR, and this is what is inside RR. Everything is, this is the complete data file. How many rows I have? I have like 1017 rows, and how many columns I have, including date, I have 6 columns. And of course, I can see that RR is nothing but 1017 observations of 6 variables. And let's say you want to do some processing. Let's say we want to access the third column, this column, third column. So what I do is RR, comma 3. I get this. I get all the the third column values. This is my complete third column. Similarly, you want to access the fifth column, the fifth column. Let's say you want to plot something. Let's say you want to plot, the fifth column. Let's not even get into fifth column. Let's say stick to, let's say the second column. This column, basically, this column. So that way we can do it is plot RR, comma 2. Okay, so I press enter and see what I get. I get all the data values, and let me just do this. TYPE is equal to L. Type is equal to line. I don't want bubbles. I want a line. That's how I can do it. I am plotting a line. That's a very nice trick, by the way. That's very nice. So we can do that. Similarly, we want to check, the distribution of the data. So we can do what we can do is hist, comma 2. Let's say the number of inches 30. Press enter. I get this. This is the distribution of my data. Let's go back to the file. And now let's go to Python. In Python or in Java or in any other language, what we do is we use sometimes in fact, what we do is we use libraries. We download libraries and then we use the functions inside those libraries. So in R, you call them as packages. The way you can download a packages, you go to tools. In fact, this is the way we do it in RStudio. You go to tools, install packages, and what you do is a window will pop up very soon. So you type in the name of the package you want to install. Let's say quantdl. I want to install quantdl, and I press install. And now automatically it will start downloading, and it can't download maybe because of net issue or maybe because of some other issue. But that's the way you generally install any package in R. And let's say in my system, I know I have the package installed already. And let's say you want to import the library. So what you do is you type simple library, type library and the name of the library, quantdl, for example. Press enter, and that's it. Complete library has been imported into my current environment. And now I can use the functions which are available inside the library. Let me come to loops. Let me come to, let's say, loops, right? So this is the syntax for my for loop. Everyone knows what a for loop is. And Python, you use like indentation. In Java or in C++, you use like curly brackets. That's what I'm doing here. I'm using curly brackets here. In fact, in R, we use curly brackets. This is syntax, right? I can run it if you want. So let's run it, because again, it's a blank loop, by the way, so there will be nothing. So let me again do something. Let me run this loop. By the way, length of RR in this case is 6. Because we have 6 variables. So let me run this loop. And if I do that, of course, I'm getting positive numbers 6 times. Why? Because look at the syntax. I'm assigning x to be 5. This x is now 5. And if I'm just checking if condition, if x is greater than 0, and yeah, in this case it is, because x is 5, so it will print positive number. It's a very nice trick. Nice, very simple, very straightforward example of loops and conditions. And let's say sometimes you want to get random numbers. To get random numbers between 0 and 1, what I do is I use simple function runif. In this case, runif 1000 means I'm getting random numbers between 0 and 1. 1000, in fact, 1000 random numbers between 0 and 1. If I press enter, I get this. I get 1000 random numbers between 0 and 1. Similarly, if I want to, let's say, get integer values, let's say you tossed a die, 6-faced dice. What could be the number that turned up on one of the faces of the dice? So the way we can do it is using this sample function. Here I'm going to draw, the syntax is I'm going to draw 100 random numbers starting with 1 and ending at 6. That means I'm going to draw 100 random numbers between 1 and 6. Replace is equal to t means replacing is allowed, because again, common sense says you're drawing like 6 random numbers only, 1, 2, 3, 4, 5, 6, and you are drawing like 100 random numbers. So obviously there will be duplicates. Replace is equal to t means duplicates are allowed. Let me just run it. Let me show what happens. See, I got 100 random numbers between 1 and 6, and of course we have duplicates. Let me just change it to F, that duplicates are not allowed. Of course, this is not possible. I'll get an error. And now let's change this to 0 and 1. Let's say I'm tossing a coin, or let's give it like this. Let's say I'm tossing a coin like 10 times. What are the possible heads or possible values between heads and tails I could get? H and T means H means heads and T means tails. So again, if I'm tossing the coin like 10 times, obviously there will be duplicates. So I can just copy it and paste it in my RStudio. Let me just press enter. Yeah. Type the result again. Yeah, see, in the first case I got like 8 heads, and next case I got like 4 heads. If you can go back and check one of my videos on law of large numbers, you understand what is happening here. And by the way, this is like a fair coin, 50-50 chance. A very quick way, in fact, is most of the time we deal with arrays. And there are many ways to declare an array in R, but one of my quick ways is using this syntax. And by the way, I forgot to talk about this operator. This is the old assignment operator of R. For instance, A is equal to 2. I'm assigning the value 2 to A. I can also do it using this operator, this arrow something operator. It's the same thing. I can change it to equal to for maintaining consistency. So let me just copy it and let me just paste it. And vector 2 is nothing but vector is nothing but, you can see vector here. Vector is nothing but number. It's a numeric array of length 6. And the numbers are these. Similarly, I can do something like this. Vector 1 is, you want to add one number, a constant value to every single number. Let's say vector of vector 1 plus 10. The number I'm adding 10 to every single number, and this is the result. Similarly, you can generalize and extend it to vector 2 into, let's say, 90. These are the values I get because I'm multiplying 90 to all these numbers. I'm multiplying 90 and 10, then 11 into 90 and so on. Let's say if one more thing. how to declare functions. The way we declare functions is using this syntax, and this is actually a check function. This function will check if it's accepting only one input argument, and it's checking if the argument is positive, negative, or 0. And this is the way we declare a function in R. This is just a simple some typical R type stuff, I should say. Function is actually a keyword, and check is the name of the function. And then I have these typical old conditions, if, else, and so on. And then my return and everything. It's very basic stuff. Everything is same if I remove this, and if I type check x, this looks like a Java function. This is the way Java works. And of course, in this case, I also have to declare, because this is Java, I have to declare the return type. Similarly, this is also the case with C and C++. In R, this is not the case. The way you declare a function is like this. You don't even have to declare the return type. Now let's copy this code. Let's paste it. And now you can see I have a function here, check function. And let's call the check function. Let's assign x to be like 99. Let's call the check function with the argument x. Let's enter. Yeah, positive. Of course, because it's like a positive number. Let's declare x to be like minus 99. And let's call the same check function. It's negative. So this is a very small, demo on R. R is a very popular language, statistical language. Scientists, statisticians, they use this language extensively in their work. And now I guess you can also start. Now you can start, I guess. You can start with, working on the basic functionalities of R. So that's it, guys. Thank you for watching. Take care. Bye-bye.